Hi, all. Very good morning. I'm Shruthi. I'm an AI specialist, and I would be presenting today's seminar on chain of thoughts. So, I assume that everybody here is aware of generative AI, LLM models, and prompting. So, this topic is a subtopic under prompting. So, as you all know, prompting plays the major role in teaching an LLM model or instructing an LLM model on what exactly you want to do with all of its knowledge that it has. It has a huge knowledge base, but how do you utilize it? You need to prompt it properly in order to utilize its energy and its capacity to the fullest, right? So when the initial prompting started with generative models in the month of 2022 November, it started with standard prompting. So as you all know, standard prompting is where you just give some basic inputs and the AI model gives the final answer as an output. Then, in the month of March 2023, we had a paper written for chain of thoughts prompting. This is totally based on proof of concept. So, if you all know, during our school days, when we used to do physics or math, proving concepts, we used to write step by step analysis on this x equal to y equal to x, so and so we used to write for a few steps to prove that this following theorem is right, to prove the theorem or to prove the concept. So that's where this entire paper came into picture, where they wanted the LLM model to write its reasoning steps in order to say or justify why it came up with this particular output. So with standard prompting, it was giving us an output, but which was just plain. We do not know how authentic or how accurate it was, and on what basis did it come up with this answer even. But with this chain of thought concept, since it's able to give us its reasoning steps, we are able to understand how its thought process is while it's coming or getting down to this particular answer. So this is all about chain of thoughts. Yeah. So this chain of thought actually is a series of intermediate reasoning steps, significantly improving the ability of LLM models to perform complex reasoning. So now, because of its chain of thoughts, it can be able to understand what are the different concepts within the question, try to break down the problem, and then try to evaluate it, because of which it can now solve complex problems. Stating this, we all know an LLM model is mostly a language model. But with this chain of thoughts concept, what they wanted to do actually is to see if this LLM model could actually break down complex math problems and logical reasoning problems and give us answers. So this went way beyond our expectation. As we all know, currently LLM models are also being used for pretty complex math solving and reasoning problems, all thanks to this chain of thought concept which came up in between. So I am displaying a short example here that is there in the standard paper. So as you can see, towards the left-hand side, we have the standard prompting where a question has been asked and the answer just says the answer is 11. We do not know how this answer, the answer says the answer is 27, but which is wrong ideally. And we do not know how it even came down to this particular answer. But the same prompt towards the right hand side by using chain of thoughts. So when the model has been taught with chain of thoughts prompting, which means the model has been fed with previous few shot examples or zero shot examples and been instructed to have a step by step analysis of the question before giving the final answer, which is chain of thought prompting, then you can see how the answer has been formulated, right? The cafeteria had 23 apples originally. They used 20 to make lunch. So now we have 23 minus 20, which is equal to 3. And then they bought 6 more apples, because of which we add 6. So becomes 3 plus 6, which is 9. So now you get an elaborate answer on how you got this answer 9, right? From the particular question. We can understand if, say for example, even if your answer is not right, but you know how it went through its thoughts, so you know that where it is missing and what extra you need to add in your prompt to make sure it understands the question better to give a better answer. So this is one major innovation that happened in the month of March. So here is another example. I went to the market and bought 10 apples. I gave 2 apples to the neighbor and 2 to the repairman. I then went and bought 5 more apples and ate one. How many apples did I remain with? And the simple answer it gives is 11. But as you can see with basic mental math that we can do here, it is not 11, right? But this is what was happening back for around 2 to 3 months before March. So now, post the chain of thoughts implementation, we can see that it kind of gives an answer like this. First, you start with 10 apples. You gave away 2 to the neighbors and 2 to the repairman. So you have 6 left. So it subtracts 10, it subtracts 4 from 10, and then it says that you have 6 apples left. Then you bought 5 more apples. It's going to add up that 6 with 5 and then give you an answer 11. Finally, you ate one. So it's going to subtract 1 and then give you an final answer 10. So now it is going to give you an elaborate answer with all the intermediate steps of its thoughts and then append the final answer to it. So coming deep into chain of thought prompting, as you all know, we have a lot of prompting techniques, starting from zero shot prompting to few shot prompting to elaborate promptings. So these are few examples where chain of thoughts could be appended with these few shot promptings and zero shot promptings. So just giving a brief explanation about zero shot prompting. Zero shot prompting is where you do not provide any example to in your prompt that the particular LLM model can infer to before answering your question. Whereas a few short prompting is where you would like to give few examples to your LLM prompt so that the LLM model can understand in what format you are expecting an answer, and based on that, it can formulate and generate its own answer. So as you can see, these are standard few shot and zero shot prompting techniques towards the left hand side, followed by CoT prompting techniques towards the right hand side. So as you can see, with zero shot prompting, you have a Q&A, question and answer sample given in your prompt, and then you ask a question and you expect the CoT to give an answer to it. So the output, as it says, all these blue lined answers are its thoughts, the blue colored answers. And the final answer is 4, which is in black color. So the intermediate steps over here are also given as an output for our inference. Now going deeper into the paper, as we got a gist of what chain of thoughts could mean here. So actually, the authors, I should say, have basically performed most of their experiments or evaluations using a few benchmarks like GSM 8K, SVAMP, ASDev, and AQA. So all these are mostly arithmetic and math complex reasoning benchmarks, followed with a few common sense and date and logical reasoning analysis models benchmark for evaluation. So stating this, I would go ahead with the properties of chain of thoughts. So first of all, what he says is the chain of this particular approach or this particular process allows us to decompose the question or the steps that you want in the question. Say for example, you have a very complex question which has multiple references within. Then it tries to uh, break down into smaller steps. So it tries to decompose these steps into intermediate steps. So when I say intermediate steps, it's going to take the first step. Say, for example, you have this question here. I went to the market and bought 10 apples. I gave 2 apples to the neighbor and 2 apples to the repairman. So what it is going to do is it is going to break down your question. Now say you went to the market, that is step one. What did you do there? Then what is the next step? You kind of parted these apples with two other people, so that would be the next step. And the other step would be you have gone to the you have bought some more apples again. That would be the third step. So it's going to divide your particular question into steps: step 1, step 2, step 3, in a more structured way, which will actually give it more understanding on what it has to do first, what it has to do next, and then try to understand the problem statement better. So, as the first statement goes, allows the LLM or the CoT in principle allows models to decompose multi-step problems into intermediate steps, which means that additional computation can be allocated to problems that require more reasoning steps. So, if it requires more reasoning, this breakdown of steps is going to allow it the time to think that, okay, this step is a bit more complex. I need to break it down further. So this is how you get your reasoning steps, because of which you can try to solve even complex problems. Okay. Now coming to the second step, how so like I already stated before, probably with standard prompting we wouldn't have understood how it has arrived to this final answer. But now with this chain of thoughts we can understand step by step on how it has thought, what was its reasoning behind this particular step, and how it has arrived to this particular answer at the end. So its entire characteristic has been of your answer along with the process has been defined in the final answer for you to give more clarity. That's step 2 of its property.
Shruti, just
Then
a quick contextual question here.
yes, yes.
So, when I'm using Chat GPT,
Hmm.
does it automatically detect that it has to do reasoning and logic?
Yes. So before 2023 March, it was completely working on standard prompting. After the introduction of papers and few other following papers, which I would mention, after it has been fine tuned to give more reasoning and chain of thoughts in its answers. So if you currently ask your chatbot this same question, right, or you say that my train is moving at a speed of 5 kilometers per hour in 3 seconds, can you give me the acceleration of it, or can you calculate um, the distance covered? Then it is going to give you such a structured answer, which with some chain of thoughts. So it is stated that the chain of thoughts prompting has been already instructed in the our chat GPT from 3.5, and with 4.55 it is even much better. Is I mean with 4 GPT 4 it is even much better is what I heard.
No, but the question is, how does Chat GPT or any other GPT know to just not answer directly, and instead of that apply COT TOT paradigm to answer the.
Yes, so that's where actually if I go down I can explain you better. Could you hold on for a minute
Sure,
with
sure,
that question?
sounds good.
Yeah,
Okay.
yeah. Thank you.
So I have another question, Shruti, can I
Yes,
ask?
please.
So this chain of thoughts, this intermediate details that it will produce as an output on the screen, or it is just everything hidden, but the author of the papers, they are writing that maybe machine is thinking internally, and this is what we are representing, and this output won't be available to the users. Are these the output, or these are just author's thought that machine is thinking like that?
Yeah. So in the paper, as per their evaluation, they are outputting all the intermediate steps. If you see, even the chat GPT is outputting all the intermediate steps, as in its thoughts. Like, as you can see, the final answer is 4, but it is giving you the intermediate steps ka results. So it would have had intermediate steps. It would have generated an answer. It is combining all those answers to have a short para of reasoning to give it to the user along with the final answer. But if you come to the concept of LangChains with agents for real-time use cases who are building on top of LangChain framework, then these thoughts are hidden and you have only the final answers displayed. Whereas you can see the thoughts on the console, but the output given to the user to the API would be the final answer. But just to elaborate,
Okay, okay.
I hope that answered your question. Yeah,
Yeah, yeah.
yeah. Thank you. Yeah. So the third and most widely used property here of CoT is for math problem solving. So, like I already stated, though the LLM model is profoundly used on unstructured data, mostly on text, videos, or speech. Many would want now to use LLM models on complex problem solving, logical thinking, and mostly business use cases, right, which deal with a lot of data. And indirectly, you would need math and data understanding for it. So, where chain of thought has played a very key role in providing adding value to the business. So that's one of the hit property of CoT, I would say. And even in the paper, they have shown or used most of the evaluation benchmarks across this particular math problem solving and common sense reasoning techniques to see how well it is performing over standard prompting. So finally, the chain of thought reasoning can be readily elicited in sufficiently large off-the-shelf language models simply by including examples of chain of thoughts. So since we can use few shot prompting along with chain of thoughts, we can give some examples of other custom knowledge that we need and the way we want it to answer, and then instruct the LLM model to go through these few short examples before giving its final answer in the same structure or format, or on what logic you would want the CoT to apply on that particular question. So, as I had already stated, they had used these three benchmarks as mentioned towards the left-hand side on the y-axis, and then we have the three models that were evaluated. They used LaMDA, GPT, and PaLM. So, this is from Google, Hugging Face, and then OpenAI, right? So these were the models on which the evaluations were made. The black lines with smaller circles indicate standard prompting, while the blue with larger circles indicate the chain of thoughts prompting. As you can see, this is the first paper released from Chain of Thoughts. And they can see that as the problem solving, as they trained further and further with more of examples and more of training data, they could see that the way it started solving the problems with Chain of Thoughts gave better results, or the solution rate was higher. And as you can see, the LaMDA from Hugging Face gave a pretty good spike while introducing Chain of Thoughts, while GPT could cross its bar and reach around 50% of solving problems with JSM 8K. This is a very, very common benchmark that is used for problem solving. So this is what mostly everybody considers. These are a bit more complex. GSM 8K is the most complex one. These are a bit complex, but not as much as GSM 8K. So as you can see, Palm gave the highest solution rate here while using chain of thoughts prompting. So yeah.
Sorry, I missed what is GSM 8K and
So
the
it is a benchmark which contains a lot of questions on math
oh,
problem
okay,
solving questions,
got it.
so which were fed to these models, and they evaluated the final answers outputted from each of the model and then gave a solution rate for these models.
Mhm.
Yeah. So as you can see, chain of thought reasoning has increased or model reasoning capacity to a great extent. So yeah, here so previously this was completely related to math solving, right? I also wanted to show how it is also working on other benchmarks and other QA dictionaries that were fed to these models. So they were also predominantly trained or evaluated on common sense QA benchmarks, strategy QA benchmarks, data understanding, and sports understanding. So now, what does common sense QA, as the word already suggests? These were benchmarks with a lot of queries related to logical thinking and common sense utilization techniques. So where these LLM models actually were performed almost to the par, because the questions were very straightforward. They did not involve any reasoning steps within. So the amount of performance was almost the same as standard prompting. Whereas when you see with strategy QA, the chain of thoughts, this paper, to be honest, now as I go down, I will introduce two other papers which have drastically increased this solution rate to a higher value. But with 2023 March, this chain of thought basics, the first chain of thought paper that was released, you can see that the statistics was for strategy Q&A as well. It was performing a bit low compared to what was performed by standard prompting. And then comes you have a Palm model performing way better compared to La MDA from Hugging Face. It kind of crossed beyond par for with solution rates. In the paper, they haven't given the Chat GPT solution model, but they have mentioned that GPT 3.5 did not perform as well as Palm model, but it did perform better than La MDA from Hugging Face. So the Lambda model. Yeah. I'll just give you a minute or a few seconds to just look through these graphs, and probably you have some questions you can ask on this. And again, date understanding here is particularly they want to, it was specific date and time related questions. So giving you certain frameworks on, say, my age was so and so, but I what would be my father's age or something like that. And questions like my train started on 25th so and so, if from India, if I'm going to reach America, what would be the time zone, what would be the date and time associated to it. So such kind of reasoning questions were asked under date understanding benchmark, right? And then comes the sports understanding, where they was fed particularly with domain specific questions, sports related questions like speed, accelerator, pitch, adaptability, the trajectory data, etc., and then asked questions on top of that for sports understanding evaluation.
So, Shruti, another doubt.
Yes.
The difference between CoT and CoT prompting, that means that in CoT prompting, I need additional prompt to work better rather than if I say it is just as a CoT. Because
Yeah.
here,
Mm.
uh, for each of these star mark, you see it is written CoT prompting.
Hmm.
So in all of these cases, I need a additional prompt from the user to work it better, or if I give
Yes.
any additional prompt internally, it will work better.
Yeah, that's a very nice question. In this paper, they have asked annotators to give additional prompts. So the COT prompting, which was manually written, was explanatory enough, was instructed to use these chain of thoughts prompting explicitly.
So if
But
I
going
don't give
forward,
prompt, if I don't give that prompt, it
mm,
don't work better. Means that I need, that means ultimately the model will work better if it needs something from outside. What if I don't give that prompt from
mm,
outside? Will it
yeah.
still work better or I don't? It will be same as
It
other.
currently does work better, but since I'm presenting the first paper that came out on chain of thoughts, the authors of this paper explicitly wrote it. But currently, now in the month of December 2023, everything is implicit. You need not externally give these steps explicitly. Rather, the model will itself understand and give you a better output. That
So
is
that
already
becomes a problem, right? Means that the thing will work better if I give something extra. If I don't give something extra, then it will won't work. So
You need not
that
give
in
anything extra. So if you mention, so when you are creating, you're deploying an LLM model, you're going to write a system prompt to make sure you tell the LLM model that what you want the LLM model to do, right? So in that, if you are going to say, for example, you want an LLM model that is going to teach physics to your kids, then you're going to instruct the LLM model that, hey, you are a physics instructor here. Whenever you're going to produce your theorems, you should produce it in step by step analysis so that your students can understand. This is all you need to give in your system prompt. And then your model is deployed. Now, say a student is using your model, your chat bot, and your student asks, can you give me the proof to prove the Pythagoras theorem? Then the student is just going to ask, can you help me learn Pythagoras theorem, or can you give me the proof of Pythagoras theorem? But the LLM model is going based on your previous instruction written in your system prompt. The LLM model is going to give a very detailed explanation to the student. So the student is not going to ask in detailed questions, right? The student is asking a very simple question, but the chatbot is going to give a very elaborate answer based on your internal modeling.
got it. But what if that additional prompt could be a biased or negatively induced or purposefully? I want some answer, and I made my prompt in such a way that I'll try to kind of push the model that give me that kind of answer because I want.
I
And
think that
I
is mostly controlled by proximal probability optimization and other reward techniques, where the LLM model, the knowledge, the base LLM model itself restrains certain negative approaches. You know, it is
mm,
restricted to such activities. There are other techniques used to restrict such activities within the LLM models.
can you mention some of those restrictions? Maybe one or two if you have. Or
Like, yeah, so there is this concept called proximal probability optimization. So where you can assign, so whenever you use ChatGPT, you give this thumbs up and thumbs down. So using that
mm,
feedback, they use the reinforcement human feedback technique
mm,
in their reinforcement learning to make sure they give assign ratings if a particular answer is negative, positive. Is it harmful to the society, or is it helpful to the society? So such kind of reward flags are assigned to each answer and each words, to be honest. So when such words, or when such combination of words are being used by the user, then automatically it gives a lower value to in your LLM model in the backend. A lower weight is assigned to it, because of which it will not answer such kind of questions. It is restricted from answering such kind of questions. This more belongs to responsible AI, and a lot of experiment and improvisation and research is going on in that area as well. Yeah. Can I go ahead, or probably we can take off
Yeah,
topic?
yeah, yeah, yeah. Go ahead. That's fine. So yeah, I mean, Partha, just to augment that. So if I as a prompter choose to, prompt it certain way, it will respond to my prompt appropriately, even though I may have not so good intent. But yes, there are guardrails using reinforcement learning with human feedback, as she said, with PPO RL algorithm. But if I as a question asker to choose to prompt in a malicious or some unreasonable way, it will have no choice but to respond to my prompt
Yeah.
appropriately, provided its guardrails are not broken. If it violates its guardrails, it will automatically stop my the from responding. Right. So
exactly, yeah,
yeah,
yeah.
yeah, we can go ahead, I guess, and take up further.
Yeah. So, just going ahead, this was the first chain of thought concept that was introduced. Going forward, there were a lot of improvisations on top of this paper. So, this is what is being more predominantly used across ChatGPT, OpenAI, and other, including Bard. So, this is the technology that is currently being used widely. So, as you can see, this is about rethinking and retrieval. Now we know that chain of thought is, it breaks down the question into the major question into multiple steps, then passes the step, gets the answer, passes step one, gets the answer for step one, then passes the step two question, gets the answer for step two, and then the final answer. So what happens here with rethinking and retrieval? We also wanted to rethink after every step. We do not want it to follow the steps blindly in a parallel format, but rather rethink if the first step, if the answer that it has generated on the first step actually adds value to the next question, get some context from the first step, and then try to evaluate the next question. If it's given an answer to the next question, check if the answer given in the second step is relevant to the first one, and how much of value addition it adds to the first one before going forward with the third step. So now there is evaluation at every step. So this is what this rethinking and retrieval concept. So this paper is actually named as rethinking and retrieval faithful LLM interface. So this is the paper, or is an extension of CoT, where they have generated a diverse set of reasoning paths. So you have multiple R1, R2, R3 up to Rn paths generated. Say, for example, this rethinking, you will there are 10 steps here. Then you have step 1, step 2, step 3, step 4, and at every step you want it to rethink R1 with an E1 explanation, R2 with an E2 explanation, so like that, Rn with En explanation, out of which you pick the best one and give the answer. So the A shows standard prompting, where you just ask a question and it predicts the answer. B shows the first paper chain of thought, where it gives you an explanation along with the prediction. C is chain of thoughts with retrieval and rethinking, where it not only rethinks, but it also tries to go back to the knowledge base, retrieve some information if needed based on the second question, rethink if it is associated with step one answer, step one's question, rethink if it is relevant to all the previous steps. Based on that, go forward, give you an explanation and a prediction.
Interesting. This is new concept. So after each step, it could rethink its approach.
Yes, that's what has improvised a lot with our. So now, when you use ChatGPT 3.5, how is it able to give you a more appropriate answer? Because it hits the tries to fetch the entire subset of knowledge database based on your question, and tries to hit that subset every time it finishes a step, and goes to the next thought for every thought.
So,
So
Shruti, my question still remains unanswered to some extent, that how does ChatGPT detect that it has to apply this complex COT, TOT and not give a straightforward general knowledge answer?
yeah, so
Okay,
that
maybe
is
I should
the
wait further for your PPT to come up.
yeah. Yes. So that's the architectural information. So internally, this is the architectural change that they have done in the retrieval and rethinking part of it, Vivek. So what is happening here is, if you see, this is the rethinking search algorithm that they have applied. Now, initially, what was happening is, every time you ask a question to the model, it, based on the similarity search and the similarity score, it gives you a result. Now, with this rethinking and re-ranking change in algorithm, what happens is, it does not retrieve all the information at once. Based on every thought, it goes back, hits the knowledge base, retrieves the information, ranks that knowledge, and then the best out of it is given to you. And then for the next thought, it goes back. Now, this entire architectural change. So when you say RAG, so retrieval augmentation generation, when you're using RAG, now inside the RAG, what is the technique used to retrieve and re-rank? That is what has been altered.
So
Interesting.
won't it take much time to respond now rather than earlier prompting? Because every time it goes to those
No,
knowledge
the
sources.
latency is pretty much balanced, because what it does is initially itself it indexes or it creates a subset from the knowledge base. It does not hit the entire knowledge base. Rather, it would have generated a subset in its first thought, right? It would have gone back to the index, generated a subset of information, retrieved it, and then ranked it. Now, when it has to go back, it need not go back to the entire concept again. It just needs to go back to the subset and then retrieve more relevant information within that subset and then rank it to give a better result. So you are not going to hit the database, the entire database every time, but rather the knowledge that remains in your cache or your retrieved memory is what you're going to hit.
Okay, thanks.
So it is not just one time, round trip for RAG for semantic search on the corporate corpus, let's say,
Hmm.
but it would have multiple,
Yes,
you need multiple
internal hits.
round trips to the corporate corpus or the embeddings.
Yes, yes, it does. And similarly, when going forward in its forward propagation, if it finds that all the ranks have failed and it hasn't given, so there is a threshold for ranking as well. Only if it is above 0. 0.8, it is going to give you the best result. So if all are below 0. 0.5, there is a threshold inbuilt algorithm as well, where it then tries to go back to the major database, hit and see if, if it can get a better subset, and then rethink its thoughts again. So this is the very big change that has been brought in with CoT. And also there is interleaving retrieval with chain of thought. So this is that interleaving retrieval. So when you say rethinking and retrieval, this retrieval is interleaving retrieval. So when I say interleaving retrieval, the word that I just stated, for every thought, for every intermediate step, it is going to rethink, it is going to retrieve and rethink. So these are the key words that I'm just mentioning for clarity. So it's interleaving retrieval and rethinking search. That is the major change that has been implemented in this paper. So I hope everybody's got a very, at least a good amount of understanding on how this chain of thought prompting is implemented, and how it has improvised our level of using LLMs for our use cases, right?
Hey, Shruti, I have a question.
Sure.
Yeah. So just wanted to kind of confirm. Are you saying chain of thought is kind of getting implemented as a part of Chat GPT newer versions itself, right?
Yes. Yeah.
Okay. And the benchmark study that you showed earlier, where a chain of thought versus the standard prompting, is that for earlier version or is that still for
No,
new?
that's the old version. This is for the old one. So for the new one, it is way beyond. We do not have, so in this paper with rethinking and retrieval, they haven't added much statistics here. But they have mentioned one thing, that with this retrieval search, so this is an algorithm paper that they have published to improvise the algorithm of CoT. With RAG and other retrieval approaches. I could not find a benchmark for GPT and Palm with it, but with the research I have done, this is currently implemented in GPT 3.5 and GPT-4, and this is the technique that is inbuilt within the model. Even the open AI model that we use along, I don't know how many of you all have used the LangChain framework, or for that, the completion method itself. They have other completion parameters added, right? Like you want to use any chain arguments or memory arguments, or I think your RAG technique, when you're going to use what percentage you want to use now, no more, even if you're trying to use the similarity of how many parameters you want to retrieve based on the top 10 selections you want to retrieve based on your similarity search, internally, the similarity search is going to work this way.
Great, great. This is pretty interesting and scary, because anyone who was working on, say, building their own chain of thought, suddenly now everything is in GPT, so they have to kind of do it all over again, right? Just to make it better. But thank you. Thanks, Shruti.
Yeah, sure. I think there are a lot more things happening much scarier. Coming to tree of thoughts. Um, yeah. So now, as you all know, we have a chain of thoughts, which is a single flow, right? It happens. It's just a one short flow. You have one question, you have one thought, then you have the next thought, then you have the next thought, and then you have the output with chain of thoughts. Whereas coming down to tree of thoughts, we would want to have multiple answers generated for a single thought. I do not want you to give me one best answer for one thought. I want you to give me multiple answers for first step one and choose the best answer in the step one itself. So, just before going down to three of thoughts, let me just walk you through these comparisons. The first one is the standard prompting. As you can see, a single input and you just get an answer, same one line answer. Then you have the chain of thought prompting, where you give an input and it tries to reason out, break down your problems into steps, and it gives an intermediate answer for each step, and then gives you a final output with a reasoning. Then comes self consistency with CO2. This is also another paper which was released before. I mean, a lot of papers have been released with chain of thought concepts and improvisations on top of it. So, with self consistency, what they do is they want to generate parallel, COTs. These are parallel COTs, and every COT is going to give you an output answer. The the outputs that receive the majority vote will be selected as the final output. So this is more like running all the thoughts, running the chain parallelly. So I will run 10 chains parallelly. Say out of which 5 chains give me 11 is the answer. Then I will choose 11 as my output answer and give you that as my answer, whichever gets the majority vote. Now comes three of thought, where I do not want to, you know, this is not parallel computing. Tree of thoughts is not parallel computing. Rather, it is more like a tree structure where I have a question asked for my step one. Say, I have gone to the market and fetched 10 apples. I have given 2 apples to my mom, 2 apples to my dad. Now, what are the possibilities here? 10 minus 2, 10 minus 4, 10 minus 2 minus 2. Say, for example, these are the options available here. These are the 3 different thoughts that is generated. Then it's going to pick the best thought out of it. Then drill down to the second thought. Make it generate multiple answers for that second thought. Choose the best answer out of it. And then do the same until it reaches the final answer. Now, this is the basic flow that it wants to adapt. Now, how will it choose if it's the best answer? Say, for example, let's take up this node. Okay. Now, or let's take up the middle one. I will just tell you. Say, for example, it has this darker shade of node, which has the highest score of similarity. So it drills down here. Now, it has 3 thoughts, 3 answers generated for the second thought, and it has scores which is 0.1, and say this is 0.5 and this is 0.9. Now this score is the highest, so it's going to go with this. But say what all are wrong. Say, for example, this is 0.1, this is 0.5, and this is 0.4. Then all the nodes are not giving you the right answers, right? In that case, it's going to back propagate, go back to the next thought, come down, elaborate that, and see if it can find a best fit answer there. Now you can ask me, if that is the case, then I need not generate all these nodes, right? What will happen? So this is my second best thought, but still this is generating a node and sub thoughts below it. Yes, it will generate sub thoughts because it wants to understand till the nth node if its final answer is right while back propagating. And it also wants to give you a second best option when you rerun the particular same question again. So they want to generate it in the form of a tree to understand how broad it can go and how many leaf nodes could be generated with the best answers. I can
I
this will
don't
be
see.
explained further.
I mean, I
Yes,
don't see the back prop happening there. There's no arrow showing back prop.
yes, there is no arrow showing back propagation, but if you see here in the logic, so in the algorithm, I will just come down to that.
Sure, sure.
The algorithm, yeah.
I mean, this is like ensemble learning or
Yes, this is
decision,
ensemble learning. Yes,
right?
you're
And
absolutely right.
or Even a neural network has these neural layers with lots of neurons, and some
Yes.
neurons get activated, some don't. So a very similar concept, but on a reasoning and thought frontage now.
Correct. Even the chain of thoughts is a similar concept, actually, but very simple. And
Mhm.
now, like you said, they wanted to bring in an ensemble technique where they wanted to have more thoughts and have more precise answers and more um make it more diverse. So they have introduced this particular concept. This was actually an inspiration from 1950s planning process paper by these authors. And the authors are Noel, Shaw, and Simon for this particular tree of thoughts concept.
See, I am
So,
foreseeing combining reinforcement learning
hmm,
with this thought tree. So in future there could be papers where RL is used to arrive at the best possible leaf node. Reinforcement.
yes. Yes, yes. Currently, there are a little drawbacks on it, and a lot of thoughts are being going on, and innovation on top of this paper tree of thoughts itself is going on. Mm, I will explain the drawbacks as well. So, if they can make this as a functionality within which you can call, like currently, one of our viewers were talking about chain of thoughts. Should I explicitly write these every time? So that's the exact drawback with tree of thoughts. You have to explicitly mention it every time. This is not inbuilt, implemented into our LLM thinking process. We have to explicitly mention it at every function, at every step. So that's the drawback that we have here. Once they wrap this into a functionality and make it more, easily accessible by the LLM, and make the math a bit more better. I think with the tree of thoughts, G of thoughts, graph of thoughts, everything is going to a different level. We will have a much better performance and reasoning capability by AIs.
I think graph of thoughts could be a problem because graph has a cycle. So if something makes a cycle, then will keep on thinking, won't finish. So I think that's why they stopped at tree instead of graph.
I think graph of thoughts is out as well. But like I said, all these papers are they are not still too much into math and formulating the code behind. These are all idea generations. They have come up with ideas and techniques, but yes, the implementation is yet to happen. It's more like if they want to get it into running for a daily use, there's a lot more optimization needed here.
Yeah.
So, why did we all even come up with Tree of Thoughts? As the paper says, it's for brainstorming and collaboration. Say, for example, if we want to solve a problem in a team, if there is a project coming up and if there's a problem statement in front of you, if we have 5 members in the team and if 5 people are able to pitch in all their thoughts, we could come up with a better solution than one person, solving the problem, right? Because he could have a biased approach, and when we have more minds, more thoughts, we can have more diverse outputs, right? So that's the main reason of having a tree of thoughts: brainstorming and collaboration, reasoning requiring math. So since it requires math, say for example, one person can solve it more optimally than the other person, then you would definitely go ahead with the most optimal approach and try to go down that particular tree or that particular route, right? Then again, coming down to LLMs trained on math, this was very, very key for math optimization problem solving techniques. This took up the optimization techniques to the next step, I would say, with tree of thoughts concept. Though math problems, basic problem solving was being done using CoT, but going to advanced and complex problem solving, we definitely needed something more than that. And with this tree of thoughts, they are looking forward to achieve the complexity, higher complexity levels in math problems, right? And then your prompting. Now, say for example, with chain of thoughts implemented, like I already stated with the physics teacher example. Say, for example, the student is just going to ask some question, and still the student has to ask, can you give me an answer for, can you give me a proof of concept for Pythagoras theorem? And then probably if it gives a few thoughts and the student needs a more elaborate answer, he has to ask again for an elaborate answer. But with this tree of thoughts, and if they're able to club all the thoughts, multiple thoughts generated together and give a more summarized answer, I think the kid will be able to get all the three different approaches along with the best one out. So he will be able to think versatile. You will be able to understand what are the different approaches in which you can take up a problem, and then learn at inference time. So on the go it's going to learn, right? While it is going to hit the database, multiple branches are going to be running so it's going to create multiple nodes and leaf nodes below simultaneously for each sub node, which is going to learn. It's going to grasp a lot more concepts at each node in the same inference time at which it's going to hit the DB every time, right? And then again, like I already said, more than one person thinking, one mind thinking. If multiple minds are going to think together, diverse lines of thinking is going to come out. So these are the few thought things on thoughts that the authors had before writing this particular three of thoughts paper. Now, inside the paper, they have mentioned these few processes or logics that they think is the best approach to follow this tree of thought concept. Now, what is the first one? The first one is thought decomposition. We already know that from CoT. Thought decomposition was already the basic, step where you break down the problem statements into small steps or words or even equations for that matter. So when I say words, it's more like when you're writing a paragraph or creative thinking. In that case, you want to break down your paragraphs into sub-statements or few n-grams or something like that, right? And then comes thought generator. Now, since in chain of thoughts we had only one thought, we that would just be another next step. But over here, you want it to generate multiple thoughts for one step, the first step itself, right? So then you take the current statement and generate thoughts, or probably the potential next steps, to increase the diversity and to see what are the ways of thinking, ways of steps that we can approach for the same thought. So you generate multiple steps. That is the thought generator. Then comes the state evaluator. Now you have generated these multiple thoughts. Now you have generated these multiple thoughts, but you want to evaluate it. So at that time, what do? You use a quantify utility. So they say that you use a evaluation utility that can decide which state of thought is more accurate and promising, and that can more help you resolve in the ongoing forward steps. So if you think that this particular solution or this particular thought is more strong and more promising towards the question, more relevant towards the question you're answering, then you would want to approach further down to this node rather than approach towards this node, right? So node pruning. So how do you want to prune the particular expansion of your tree? How do you want to stop it? By using the state evaluators. So that's where pruning comes into picture. And then you want to also use a search algorithm. Now the search algorithm is this three part. So that's where Vivek, the back propagation comes into picture. So in your search algorithm, there are two approaches to it. So you have the breadth first search algorithm and the depth first search algorithm. So in your breadth first search algorithm, as you can see, say for example, S0 is your step 0, and you have given an input to step 0. And this is your node 1 out of depth T. Now this T is undefined because this is breadth first. So with your node 1, you want to generate. So you want this generator to generate as many thoughts possible for this step 1. and then you want to evaluate each thought and then choose that thought and then go down. So this is where the breadth first algorithm comes into picture. So in the paper, they have used around 3 to 4 techniques to evaluate this concept. So one is something known as Game 24. Uh, I'm uh, I'm sure you guys will know what is Game 24. If not, I will just explain you. They will give you a list of numbers and they will ask the algorithm or the model to choose what are the combination of numbers with different, board mass techniques or um, uh, different equations with which I can obtain the number 24. Right? They're going to give you a list of numbers, and if to reach the number 24, you can do any permutation and combination you want, and using any arithmetic operation. So this is actually a pretty complex question to an NLP model, and they saw that using this breadth first algorithm, they were able to achieve this in less than 3 steps. So when I say less than 3 steps, it went down to only form 3 levels of the tree, level 1, level 2, and level 3. At the third level, they were able to get the answer for it using the breadth first technique. So uh, So the initial thought steps that could be evaluated and pruned down to a compact set of 5. So the breadth. So when I say breadth, the number of nodes, the sub thoughts that were created. So we're like 1, 2, 3, 4, 5. Within 5 nodes and a depth of 3, they were able to solve this particular game 24. Paper or the problem statement, actually. Not a paper, it's a problem statement. Yeah. Now the same thing, there is a different search technique also that could be applied onto your tree of thoughts, which is depth first search. So I do not want to go breadth wise, but I want to go depth wise. So when I have to go depth wise, then I take the current state, I step down, then I go through the thoughts, then I go into the thought to the next node, to the leaf node, and go to the sub nodes down below. Now, what if my sub node stops at one point? Say something like this. My sub node over here stops at this point, right? I do not have anything further. This has given me very low, not a promising answer. My score is 0.1. Again, how it is scoring, the evaluation part I will explain you. But as of now, I'm just giving you a scenario where, say, for example, this is 0.1 and this is 0.3. Now I know I can't do anything here. Now I have to backtrack, go back and go into the next depth, which is going to give me the better answer. When I come down here, when I go into this depth search for this particular second node, then I know that this node gives me a better answer. And now this gives me a better answer. Now, how do I know that this is the best answer? I need to go back and check the next nodes as well. So I backtrack, go to the next node. I find that this answer is not valid. So I get down and say that this is the best answer, right? This is the depth first search approach algorithm. And what have they evaluated this on? They have used this for crossword solving. So as you can see, they have evaluated these techniques on 3 different problem statements. One is game of, the other is for creative writing, and the other is 5x5 crossword solving. These were the inputs that they gave, and this was the best output solution that it gave out. And these were the 3 intermediate steps that it chose to be the best amongst all the steps that it had taken. And I will show you all these. This is just a basic statistic table that they have provided in the paper. Just going into how the model performed during each of the problem statements. Once they have given the input with 4, 9, 10, and 13, it passes into the first step. The first step is thought decomposition. Okay, it tries to break down the problem. So the first thought, it tries to do is it first tries to take the different numbers, right? The combination of numbers that it wants, and then generate the thoughts for a thought generator. So, and generate the thoughts for it. So, what are the thoughts it has generated? 4 plus 9 equal to 13, 10 minus 6 equal to 6. So, what is left out? Similarly, many more. It has generated some n number of thoughts here. Now, it has generated all these thoughts, but I want to evaluate it, to prune it and make sure my tree is not like never ending, right? So I want to evaluate how strong these answers are or how promising these answers are. Then it comes to evaluation, prompt evaluation. Now, the prompt evaluation, how does this evaluation actually happen? Now, there are two ways to evaluate this. There is value evaluation and there is vote evaluation. Now, this example shows value evaluation. So where they take the value, and the evaluation result is given in the form of a percentage of how promising it is, so how accurate it is. So for example, if it is 60% accurate, then I will go ahead with this answer. If it is 80% accurate, then I'll go ahead with this answer. So these are percentage wise value prompting. Now value evaluation. Now there is vote evaluation also, which comes in the later step, which I will explain. So this is how the thought evaluation or the state evaluation takes place. Once it is evaluated, the results are here. So as you can see, um, 13 minus 3 into 13 equal to 3 into 13, which is equal to 39. This doesn't give you 34. Sorry, this doesn't give you 24. There is no way to obtain 24 with these numbers now. So it says this is impossible. And then similarly, this is just one example. There could be multiple thoughts generated, and then multiple evaluations take place, and whichever is the best evaluation. So each evaluation is given a square, is given a score. So it is not like it is neglected, right? So every evaluation score is maintained. So it is come down to this tree. This evaluation is done, the score is maintained here. Every node, every evaluation score is maintained, and every state is preserved. Whether it has to expand beyond that state or no is only defined by the state evaluator, not whether it has to eliminate the node. Who does the elimination? The search algorithm does the elimination. The breadth search, the breadth first search algorithm, and the depth first search algorithm does the elimination of nodes and chooses which is the best node. Okay, so this is with the game of 24, and this is how it performs with CoT and ToT, with the chain of thoughts and tree of thoughts. So if you can see, this is the tree of thoughts approach here. It's like way beyond chain of thoughts, and the amount of error that it gave out. So how many wrong answers it had, it generated, how many times it generated a wrong answer is very minimal, as you can see, compared to chain of thoughts. So this is the error analysis, and this is the success rate or the evaluation score analysis.
So this B is branching factor, B is equal to 5.
Sorry, where is it?
B, the TOT bracket, B equals to 1 to 5.
Yeah, it's the
So
breadth. It's the breadth. Yeah, it's the branching.
the branch.
Yes.
So how much is this different with the decision tree building? Like if I consider DFS.
Yeah, it
depth
is an
first.
ensemble technique. Like Vivek already told, this is an
Yeah,
ensemble technique which they have taken up. This
ensemble.
coming into LLMs, introducing ensemble techniques within LLMs. So we know decision tree, it was there in NLP. Now within generative AI, within these LLMs, how can we ask them to behave, use this technique of ensemble or bagging or boosting,
Okay. Yeah.
So here comes creative writing. So like I stated, they used three different problem statements, right? The second problem statement was creative writing, where they gave their thoughts on what they wanted to write the story on or write the paragraph on, and it generated, say, if you have given they have used b equal to 5, breadth equal to 5, so it will create 5 different nodes and then branch down to sub nodes. Okay, so as you can see, it has generated 5 plans, and out of that, it is wanting to vote for every plan. So at the evaluation state, so the generation state generates these 5 plans, and then the state evaluator tries to evaluate them. Now, once the evaluation is done, it sees that this paragraph receives 0 votes, and say this plan 3 has received 1, plan 5 has received 2, and plan 2 has received 3 votes. Now, this is the maximum votes it has received, which means this is the evaluation technique. So previously we saw value evaluation. This is vote evaluation, where it votes which answer is the best and tries to get the best vote out, and then it chooses this as the answer and then goes down to the next thought to improvise this further based on your input question. Okay. So again, with creative thinking, as you can see here, with CoT and ToT, there is not much difference, because unstructured data pretty much works well all the time. So there is no much difference here, as you can see. Even when it is refined, so when they say refined here, when you're giving a better prompt, a more instructive prompt, still you can see that the difference is not that big, right? Yeah, it is better, but it is not that big compared to CoT or IO for standard prompting, for that matter. And you all know the reason behind this. It is an LLM model. It is a language generator model, which already works very well on unstructured data. Since creative writing is all about generation, it pretty much works well in that case already. Then comes the mini crossword results. As you can see, for this mini crossword, we all play crossword puzzle, right? Where we have words along. So it's X cross X you have, and then you try to write A, then you have a space, and then you have T, and you have to fill the space with N, say ant, A-N-T, ant, and find the crossword. So what's the next crossword? I give you another hint for the next word across the line, and then you have to guess what's the word. So that again happens with a lot of permutation and combination of letters, which was again done very well by ToT. As you can see, with basic prompting, we could achieve only 38% of success rate, but with tree of thoughts, it gave up to 78% of success rate, which was like huge. So it could, since it was language and not numbers, and since it also had a structured way of thinking, and it could permute and it could do permutation and combination along its thoughts using various characters. So it actually gave a better answer within 5 nodes branches itself, so which is like really good, right? Now this is an example which I found on the internet, where one of the users stated that he could, try this on GPT-4, and he got a tree of thought kind of answer from GPT-4, but I could not get a valid. I do not know how authentic it is, but I just wanted to state it if anybody is curious to try this tree of thoughts on GPT-4, if you have an upgraded version, and then you would like to try this. Okay, but I just thought I will run through a decomposition of his particular thoughts. Imagine that there are 3 different experts answering this question. They are brainstorming the answer step by step, reasoning carefully, and taking all facts into consideration. So the use of taking all facts into consideration is what he states is helping him create different branches. Okay. And then all experts will write one step. So he says that now he has stated that you have different thoughts, taking into consideration all the thoughts, and each thought will have one step. So he's actually explicitly writing down a tree algorithm here, and seeing how it is working on chat, just for an experiment purpose. And then I actually leave it to your curiosity to find the answer for this. I will definitely share this PPT. You can go through these steps. He had definitely printed out some answers, but I did not want to share it so that you guys are curious enough to go and try this on your own and see what kind of answers you get. Yeah, that's about tree of thoughts. I think the path ahead is very huge. There's a lot of innovation required under tree of thoughts. So what are a few drawbacks from tree of thoughts is, one of you were asking for chain of thoughts. The thought process should be explicitly explained by the user right now. So like how I'm showing an example here. Without this, the system will not be able to understand that you want to actually generate multiple thoughts and go diverse into those thoughts. So uh, right now there are a few coders who are trying to implement this algorithm. A few state that they have successfully done it and you can use it, but again there is no authentic approval given out by any author to state that whatever they have mentioned in the paper is what is implemented by the person, by the programmer. So there is no legitimate proof that ToT is successfully running out there. But I can also, there are other newses out there that um, um, Google and OpenAI are trying to implement this ToT into a whole new separate model in their next new LLM model that is going to be out. But for that, they need only if they're trying to create this as a functionality and give it as a wrapper to us. Like say, for example, if we say ToT equal to true, and then we try to give a prompt, and if it is able to, answer to us with the ensemble technique, then it would be useful. Otherwise, writing an entry level prompt this big is going to be very expensive for us and time consuming as well, right? So definitely they're working on something more optimal towards this tree of thought. And again, up next is the GOT, which is graph of thoughts, which the paper is already out and many people are exploring that as well. So I think there's a very, very long way to go. Thank you all. Thank you so much for patiently listening. I hope it was helpful and it was informative. Thank you. Any questions?
So incredible presentation. Now there are some questions on the chat, if you don't mind.
Sure. Yeah. Okay. Okay. Hi all. Yes, try to join. X equal to number of parameters, Y equal to percentage of solution. Okay. How you compare the answer, whether it's wrong or right, produced by LLM models? Again, these evaluation techniques, like I just showed you, are again value evaluation and vote evaluation. If you see, value evaluation is still similar to the similarity score that we have. But the LLM model evaluation is currently done only based on benchmarks. So when I say benchmarks, there are already standard Q&A benchmarks set up there out to evaluate these models, and based on that only, right now the success rates are measured. They are trying to use third-party evaluators, but I do not see much success in that part. There's a lot of work going on that. Currently in the paper, how they are evaluating is using value evaluation and vote evaluation. Value evaluation is mostly on similarity score. Vote evaluation is like a classification technique where it's a yes or a no. Okay. And then comes share something on metrics workbench. Okay. Is this diagram the evolution from older days to now? I do not know which diagram you were mentioning on, but the CoT that was out there, the CoT concepts that I explained you first were the old paper from March 2023. Definitely, there have been a lot more improvised research and papers let out on CoT until date. Even now, there are certain papers that are being written on CoT. So there's constant improvisation happening on top of tree of thought. These are all concepts that have been introduced. But there's a long way to go to perfectize it, or great minds and great thoughts coming out in those areas. Then comes Chat GPT Plus already gives us multiple outputs with an option to choose which one we have. Yes, but those multiple thoughts are, again, like I showed you, it's the self-consistency CoT. They are not ToT. So it is chain of thought concept where they have multiple answers generate. So if you see on my slide, yeah. So this is the concept with which GPT Plus is currently giving you answers, right? With the majority votes, and it's giving you options to select. If you choose this option as the best, you give a thumbs up. So what it is trying to do is it has already a self-consistency CoT within. it is going to say, for example, out of the 5, these 2 are the best. It's going to give you these 2 options, and you choose the best, out of which it is going to give a higher ranking to this. And during its reinforcement learning using human feedback, it is going to improvise further on its output later on in its further GPT models, right, in the future. So this is what their technique is currently, to improvise their models. And what is next? Is there any way to implement tree of thoughts using LangChain? Definitely, I was looking one for that. Yes, I found one, but again, he is using Python libraries inbuilt to implement the logic. I think the LangChain CEO hasn't approved that code yet, because it is not consistent, and it is not giving the right outputs. So there are a lot of people contributing towards the tree of thoughts code onto the LangChain to develop it into a framework. But yeah, it is still not out there, to be honest. And even the chain of thoughts is only as a part of agents, right? There are a lot more improvisation needed on chain of thought agent concept, which is chain of thoughts under LangChain itself. And thanks for this session. I mean, I have been explicitly called, do we have a framework for this to be done? So for CoT, we already have a framework available on LangChain, and we also have other codes available if you're using Llama 2 or etc. But whereas for ToT, it is currently not present. It's still under work. Yeah, I think that's it. Only these many questions, Vivek.
Yeah, friends, any other final questions for Shruti here? So Shruti, I was hoping for a code demo, but that's fine. The paper presentation is absolutely marvelous, extremely well done. Thank you for your work, and learned a lot about the CoT, ToT. And I'm very pleased to have discovered a talent of your caliber, and would love to talk to you offline for more collaboration on our product team. And of course, I look forward to your future presentations. And you can see the audience feedback is absolutely marvelous.
Thank you, Vivek. Thank you
Yes,
for giving
definitely.
me this
It's a
platform.
fantastic presentation. Thanks a lot for sharing. Very, very knowledgeable one. It has a great insight. Thanks a lot for sharing, Shruti.
Thank you a lot. Thanks, everyone.
Thank you all. Thank you, audience, for joining. Thanks, Shruti. Have a good weekend. And we do have another webinar in next couple of hours, so do attend. Thank you all for joining. Thanks once again, Shruti. Bye then.
Thank you, everyone.